Okay, so 2m to the fourth negative 1 to the first power plus blank 2m decrease the power of 3 negative 1 squared plus blank 2m to the second power negative 1 to the third power plus blank 2m to the first power negative 1 to the fourth power plus blank 2m to the 0 power negative 1 to the fifth power. So now that you have this set up, all you need to do is put your coefficients in. This is Pascal's triangle, the fifth row. So the fifth row goes 1, 5, 10, 10, 5, 1, but you could do 5 choose 0 here, which gives you 1. 5 choose 1 here gets you 5. 5 choose 2. 5 choose 3. 5 choose 4. And then 5 choose 5. Okay, so now you have to kind of clean this up a little bit. What you want to do, just look at each term at a time. This is negative 1 to the 0, which is 1, positive 1, times this piece. And this piece, you actually have to do 2 to the fifth power first. So that's 2 to the fifth power times m to the fifth power. All of this stuff gets raised to the fifth power. And then you times it by 1, and then you times it by that one. So this first expression just ends up being 1 times 2 to the fifth power. So all I'm going to do is just raise 2 to the fifth power, and that gives me 32. So that's 32m to the fifth power for this first expression. Okay, so this next expression, well, I have a 5 there, and then I have to take 2 to the fourth power, and then m to the fourth power, and then negative 1 to the first power remains negative 1. So now I'm going to multiply 5 times 2 to the fourth power, and then I'm going to times it by negative 1, and I get negative 80. So that's actually negative 80, and then the m4 is there. The next piece, I have 10 times 2 to the third power times m to the third power times negative 1. Oh, negative 1 squared is 1. So now all I have to do is just do 10 times 2 to the third power and times it by 1. So I get 80 positive. So this is 80m3. The next piece, well, the next piece is 10 times 2 square times m square, and then negative 1 to the third power remains negative 1. So this is actually 10 times 2 square. So you got to do the squares first. 2 square is 4. 4 times 10 is 40. And then you have your m squared that's still there. This next piece, let's see, we have 5, and then we have 2 to the first power, m to the first power, and then negative 1 to the fourth power is positive 1 now. So that's just 5 times 2, which, well, first I would do 2 to the first power, that's 2. So 2 times 5 is just 10. And then I have a m that's left. And then this piece over here, 2m to the 0 power is 1 times this 1, and then that's negative 1 to the fifth power, which remains negative 1. So if I rewrite this, this is 32m5 minus 80m4 plus 80m3 plus, oh, actually, this is supposed to be a minus here because that was a negative 1 times that. So it's a minus 40m squared plus 10m minus 1. And that's my binomial expansion of the 2m minus 1 to the fifth power. Okay, so on to the next one. So now we have 3x plus y. We're going to expand it to the fourth power. So let's start again. Leave a blank spot. Pick this piece and then start off with the fourth power. Pick the y. Start off with the 0 power and then do it again. Blank 3x to the third power, y to the first power, plus blank 3x to the second power, y to the second power, plus blank 3x to the first power, y to the third, plus blank 3x to the 0 power of y to the fourth power. Okay, so then we need to fill in our coefficients. Pascal's triangle says the fourth row is 1, 4, 6, 4, 1. So we fill those in, and now we just have to multiply everything out. So I'm going to do this piece first. That's 3 to the fourth power times x to the fourth power, and then y to the 0 just becomes 1. So this is just 3 to the fourth power. So 3 to the fourth power ends up being 81x4. This next piece, 4 is still there, and I have 3 to the third power, x to the third power, raise both of these stuff inside to the third power, y to the first power. Here, I'm going to do 3 to the third power first before I times it by 4. So 3 to the third power is 27. 27 times 4 gives me 108. So that's 108 x3y. This next piece, I have the 6. This is 3 to the second power times x to the second power times y to the second power. So 3 to the second power is 9, and then 9 times 6 is 54. X squared, y squared. Okay, the next piece, well, 4 times 3 to the first power, x to the first power, y, 3. Well, 3 to the first power is 3, times 4 is 12. I have my x, I have my y, 3. And then over here, I have 1, and then I have 3x to the 0, which all becomes 1, and then y to the fourth, which is just what's left is pretty much a y to the fourth. So that's right here is my binomial expansion. Okay, so this next part, they don't want you to expand all of them because this is 3x minus 2y to the 12th power, and it's going to be this really long expansion. So they just said, well, what is the coefficient, the number in front, when you have a x5, y7? So to do that, this is what I'm going to do. I'm going to start off, well, this is to the 12th. So I'm all the way here at already at the 5th term. And so I'm going to leave a blank spot, and then I'm going to say 3x to the 5th term. And then this is actually plus minus, so that's actually a negative 2y times negative 2y, and then 7 to the 7th. And if you haven't been noticed, the powers actually add up to this power here. 5 plus 7 is 12. Up here, if you guys look at it, it's the fourth one, and that's 4 plus 0 is 4. 3 plus 1 is 4. So all I have to do is clean this up. And here, this part, it's going to actually be 12 choose 7. Or you can actually do 12 choose 5. It'll give you the same piece. So calculator, math, probability, NCR, I'm going to do 12 choose 7. That's 792. And then this piece is 3 to the 5th power, x to the 5th power, and then this piece is negative 2 to the 7th power, y to the 7th power. So once I get it to look like this, I'm going to do all the exponentials first, and then I'll times them all the numbers together. So 3 to the 5th power ends up being 243, 792, x5, and then negative 2, I'm just going to do it here, negative 2 to the 7th power is negative 128. And then I have a y to the 7th. So then now I have to do 792, 792 times 243 times negative 128. And when I multiply that out, I get this really big number, negative 2463438. And then I have a 5, x5, y7. That's what we want, the coefficient in front of the x5, y7 term. Okay, so the next example is, it's again a really big expansion to the 15th, and we don't want to do it all the way to 15th. So they just said, well, just give us the first 3. So if you want the first 3, you got to set it up. Here's the blank spot. This is 3p to the 15th times q to the 0 plus blank 3p to the 14th q to the 1 plus blank 3p to the 13 q squared. So again, I'm decreasing the power of the first term, and I'm increasing the power on the second term. My coefficient, well, this is the 15th power, so I'm going to do 15 and then choose 0, 15 choose 1, 15 choose 2. And then on my calculator, I'm going to find those values. So math, probability, NCR, 15 choose 0. Hey, that's 1. So this piece becomes 1. I still have 3p to the 15q 0, which is just 1. And then the next piece. So let's do 15 choose 1. Well, that's 15. And then that's 3p to the 14. And then this is q1. And then over here is 15 choose 2. So I'm going to use my calculator to find the 15 choose 2. So I'm going to go 15, and then I'm going to choose I'm going to choose 2.